It's amazing to think about how fast things are changing in the car world.
Oh, yeah.
I mean, it wasn't that long ago that self-parking cars seemed like something straight out of science fiction, and now we're actually talking about vehicles that can completely drive themselves.
Right.
But with that huge leap forward comes a really important question for everyone. How do we make sure these self-driving cars are going to be safe?
That's the core issue, isn't it? As these autonomous systems get more complex, the chances of something going wrong get bigger, and the consequences of those errors become way more serious.
Exactly.
Safety is not just a bonus feature anymore. It's absolutely fundamental if we want people to trust and actually use self-driving technology.
Which brings us to what we're focusing on today. NVIDIA just announced this big new safety system specifically for autonomous vehicles. They call it Halos.
Halos's is a pretty big deal. It's, like you said, a full-stack approach, which means it tackles everything from the huge computing power in the cloud used for training and virtual testing, all the way down to the computers on board a self-driving car itself.
Yeah, it seems like they've taken all their existing safety tech for cars, both hardware and software, and put it all together with their latest AI research with that specific goal of making self-driving cars as safe as possible.
Right.
So our mission today is to really break down the core parts of this Halo system and figure out what it means for the future of safe self-driving cars. And we're going straight to the source for this using NVIDIA's announcement itself.
Okay. Sounds good.
One of the big ideas NVIDIA talks about is the growing importance of what they call physical AI.
Okay.
This is where AI goes beyond just crunching data and really gets deeply integrated with the physical world, which is exactly what a self-driving car has to do.
Okay, so let's dig into this physical AI concept a bit more. What exactly makes it so crucial for these self-driving cars?
Well, the key point here is that traditional AI, which might do great in those controlled digital environments, has a real tough time with the unpredictable nature of the real world.
Right.
An autonomous vehicle isn't just looking at still images, it's constantly sensing and reacting to a world that's always changing. Makes sense.
So physical AI stresses that tight link between seeing, understanding, and then acting, so that perception, planning, and control all work together seamlessly. That ability to process information and make decisions in context, that's the fundamental step needed for truly safe autonomous driving.
That makes total sense. So it's more than just identifying a pedestrian. It's about understanding where they're likely going, how fast your vehicle is moving, the conditions of the road, and then making a safe decision in that very moment.
Yeah, exactly.
And NVIDIA really emphasizes that choosing the right technologies and frameworks is absolutely essential for the safety of everyone, both inside and outside these vehicles.
Exactly. And Riccardo Mariani, NVIDIA's VP of Industry Safety, he puts it well. He says, Halos is meant to empower their partners and developers to create their own unique products, but while still all working towards that common goal of autonomous vehicles that are not only safe, but also reliably safe. So that's kind of the goal there, is that it's safe and it's reliably safe.
And he brought up another really interesting point, that Halos could potentially work alongside existing safety measures and could even help speed up the process of creating industry standards and regulations for autonomous vehicles.
Yeah, that's a key point. We're still really early in the process of figuring out comprehensive safety standards for these autonomous vehicles. A system like Halos, which offers this really well-defined and thorough safety blueprint, could be a valuable framework for both regulators and the car industry to build upon.
So NVIDIA describes Halos as a total safety system structured around 3 interconnected dimensions. What are those 3 key areas?
So those 3 dimensions are technology development and computing.
Okay.
You can think of them as 3 essential perspectives or lenses that NVIDIA is using to tackle the really complex challenge of safety in autonomous vehicles.
Okay, so starting with the technology dimension, what does that cover?
The technology dimension, it really deals with the fundamental building blocks. So those core hardware and software platforms, the AI algorithms that drive the whole system, and also the safety considerations baked into the whole ecosystem of partners and developers using NVIDIA's tech.
Okay, that makes sense. So what about the second dimension, development? What's the main focus there?
Development really focuses on the processes and safety checks that are in place throughout the entire creation of an autonomous vehicle from start to finish.
Right.
So this involves what NVIDIA calls setting up guardrails during the initial design phase and then throughout the entire software deployment. And super importantly, in the continuous testing and verification to make sure that safety performance stays at the highest level.
That's logical. It's not enough to just have parts that are safe on their own right. You have to make sure they're used and tested rigorously for safety at every single stage.
Exactly.
And finally, we have the third dimension, computing. What does that one entail?
So the computing dimension, this one addresses the huge amount of computational power that you need to train the AI, run tons and tons of simulations, and then finally actually run the autonomous driving software in the car itself.
Right.
And NVIDIA really highlights the role of 3 of their super powerful computing platforms in this whole process.
Can you walk us through those? Where does each platform fit in?
Sure. So first up, for the really, really demanding job of AI training, which is all about feeding these massive data sets to the neural networks so they learn how to drive safely, NVIDIA uses their DGX systems.
Okay.
Then for the essential phase of simulation, where you can test these autonomous vehicles in a practically infinite number of virtual scenarios, they use NVIDIA OVX.
Got it.
This powers their NVIDIA Cosmos simulation platform, which runs inside their broader NVIDIA Omniverse.
Okay.
And finally, for actually deploying the autonomous driving software in the vehicle itself, the key technology is NVIDIA Drive AGX.
Okay, so it's a complete end-to-end computing pipeline, from the initial learning that happens in the cloud to the real-time decision-making happening right there inside the car.
Yeah, exactly.
Now, Marco Pavone, NVIDIA's VP of AV Research, brings up an interesting point about the current trend, where a lot of companies are really into these end-to-end AV systems that are driven by generative AI.
Right.
What's his take on this, and how does Halos fit into that picture?
Well, what's really insightful is Pavone's warning that in all the excitement about these new AI systems, we shouldn't forget about traditional design and verification methods.
Okay.
He's suggesting that while generative AI has amazing potential, a comprehensive safety strategy like Halos, which blends cutting-edge AI with those well-established safety engineering practices, is super important. It's about having this really robust, multi-layered approach instead of just relying solely on the AI's capabilities.
So it sounds like he's pushing for a kind of belt and suspenders approach to safety, especially considering how intricate these AI-driven systems are.
Yeah.
Now, NVIDIA is also introducing this thing called the AI Systems Inspection Lab as the entry point to Halos.
Right.
What exactly is this lab, and who is it designed for?
You can think of the AI Systems Inspection Lab as this specialized facility and program where car makers and other tech developers can go to make absolutely sure that their own products and tech integrate safely and smoothly with NVIDIA's platforms.
Okay.
It's like a way to ensure compatibility and adherence to safety standards right from the get-go during development.
And this isn't just some concept on paper. It was just announced at CES 2025, and it's a big deal because it's the first international program to be accredited by the ANSI National Accreditation Board for its comprehensive safety framework, covering not just functional safety, but also cybersecurity and those important AI safety regulations.
Right. Yeah, that accreditation from AAB is really important. It shows just how thorough and trustworthy the lab's processes are, and the fact that it combines functional safety, cybersecurity, and AI safety all into a single framework really highlights how interconnected all those aspects are when it comes to ensuring safety in autonomous vehicles.
Right.
You can't really address one without thinking about the others.
And they've already got some major players signed up as initial members, including Ficosa, Omnivision, Onsemi, and Continental, which shows that the industry is definitely interested in this kind of verification program.
Absolutely. And Christian Casaran Antinuelo from Ficosa's ADS engineering and product management teams, he points out how important it is to be at the forefront of automotive system innovation and reliability by joining the lab. It shows a proactive commitment to making sure their tech is validated for safety.
So let's dive a little deeper into the 3 core elements that form the basis of Halos platform safety, algorithm safety, and ecosystem safety, starting with platform safety. What are the key features there?
Okay, so platform safety, this starts with the most basic building blocks.
Okay.
So you've got their safety-rated system on a chip, or SARC. This is like the brain of the vehicle's computer system, and it's designed with hundreds of built-in safety mechanisms at the hardware level to stop malfunctions from happening.
Got it.
Then there's NVIDIA Drive OS, which is their safety-certified operating system. This covers everything from the central processor to the graphics processing unit, giving them a really secure and reliable software foundation.
Okay.
They also offer a safety-rated platform that provides all the necessary computing power to implement safety features across different applications within the vehicle.
Okay.
And finally, Drive AGX Hyperion. This acts as the central hub. It's the hardware platform that connects the SOS Drive OS and all those different sensors in the car's electronic control unit architecture.
So it's like a multi-layered approach with safety built right into the core hardware.
Exactly.
So now let's talk about algorithm safety. How does Halos make sure the AI models themselves are safe?
So algorithm safety focuses on making sure those AI models are really robust and behave predictably and safely in all kinds of situations.
Oh,
So this includes things like safety data loading, making sure that the data used to train the AI is high quality and appropriate.
right.
NVIDIA also provides these special software libraries that are optimized for their hardware and programming tools that help with creating, managing, and analyzing safety-related data. So this lets developers filter out any weird behavior or biases before the AI even starts learning.
Right.
NVIDIA also uses its Cosmos World Foundation model and Omniverse blueprint for AV simulation to build these incredibly realistic and diverse virtual environments for training, testing, and validating how the AI performs.
Okay.
And crucially, they emphasize using both modular software components and end-to-end AI models in their various autonomous driving software stacks, and they're constantly assessing the safety of these advanced AI systems.
So it sounds like they're trying to build safety into every step of the AI development process, from the data the AI learns from to how it's tested and validated.
Yeah, that's the goal.
And then there's the third core element, ecosystem safety. What does that one involve?
So ecosystem safety recognizes that making sure these autonomous vehicles are safe requires everyone in the industry to work together. This element includes providing safety data sets that are carefully curated to be diverse and unbiased, which is really important for training AI that's fair and reliable.
Right.
They also have this structured process for safe deployment, which includes continuous data collection and analysis so they can keep improving safety. And they use standardized workflows with automated safety evaluations built right in it.
Okay.
NVIDIA really wants to emphasize that this part of Halos shows how committed they are to taking the lead in establishing industry-wide safety standards and regulations for autonomous vehicles.
It's clear that NVIDIA is making a big push on safety with Halos, and it's not just some new thing. They're really highlighting all their experience in this area, and the stats they're sharing are really impressive.
They really are when you look at the numbers. Over 15,000 years of engineering effort dedicated to vehicle safety. More than 10,000 hours contributed to international standards committees. Over 1,000 patent applications specifically about autonomous vehicle safety. More than 240 research papers published on AV safety. And over 30 safety and cybersecurity certifications. It really shows a deep and long-standing commitment.
Those numbers are amazing. It really highlights how much they've invested in this.
Yeah.
And Halos is directly linked to some big safety certifications and assessments they've gotten recently. Can you tell us a bit more about those?
Yeah, those recent certifications really back up all their safety work.
Okay.
Their Drive OS 6.0 operating system got the ISO 26262 Automotive Functional Safety ASIL-D grade, which is the highest level of safety integrity you can get in the car industry.
Wow.
And then TUSD, which is a super well-respected independent testing organization. They gave NVIDIA the ISO 21434 cybersecurity process certification for the automotive SOCs platforms and software engineering processes. This recognizes how seriously they take cybersecurity. And lastly, TÜV Rheinland did an independent safety assessment following the United Nations Economic Commission for Europe's guidelines on the safety requirements of complex electronic systems for NVIDIA Drive AV, so that further validates their safety measures.
So to sum it all up, Halos seems to be a really comprehensive and multifaceted strategy to ensure the safety of autonomous vehicles.
Yeah.
It's not just a single piece of technology or a single procedure. It's this whole system that covers the entire life cycle of the vehicle, from the basic hardware and software to those AI algorithms and the whole network of developers and partners.
Exactly. It's how those three dimensions, technology development and computing, are all linked together that really makes Halos what it is.
Right.
And the AI Systems Inspection Lab acts as that crucial first step for partners to integrate their products safely within this whole framework.
And when you take into account NVIDIA's long history and continued dedication to automotive safety, it really adds weight to this new Halos system. It's clearly built on a solid foundation of expertise and investment.
Yeah, for sure. That track record combined with those tough certifications really builds trust as they introduce Halos. It shows they're serious about making autonomous vehicles as safe as they can possibly be.
So as we wrap up this deep dive, it really raises some big questions.
Yeah.
Given how complex AI is in self-driving cars, how will these types of comprehensive safety systems like NVIDIA's Halos ultimately shape public confidence and speed up the widespread adoption of this technology that could really change everything?
Right.
And what are the challenges and practical considerations that will inevitably come up as these advanced safety measures keep evolving and being put into practice? Definitely some food for thought for all of us.
Absolutely.
Thanks for joining me.
Thanks for having me.
And then thank you all for listening.
Yeah, thanks everyone.